Mariano Pierantozzi, Prof. Mariano Pierantozzi, here in our university during this week. He's going to give this conference, and next day he's going to give a seminar to some of the students here of physics degree. He's a mathematician, but after doing his degree in mathematics, he started to build models with physics property. So in the end, he makes his writes in doctoral thesis on physical properties and equation of state for physics. He's a associate professor at the University of Valenciano, that is in Pescara, in Italy, and he has been researching about neural networks. We have collaborated for several years, and we have published 2 papers in international journals, together with García and Mariano. He's going to talk us about neural network. Moreover, he has a channel in YouTube with more than 130,000 followers. So he's known in Italy, known in Spain because he speaks in Italian there, but he's a very good communicator. I hope you can enjoy. And if you have questions at the end of the talk, you can ask him or talk to him at the end. So it's your turn.
Thanks a lot. I ask you pardon for my English, but if I do not remember some words, perhaps I will tell you in Italian because it's quite similar. So, about me, Engel told about me. I am an associate professor at University of Pescara. I teach technical physics, but I am a mathematician. So I am a mathematician that teaches physics sometimes also to engineers. So I do not know a lot about me because I studied one thing, now I have to teach another things, and to some persons that is not on my field. For example, a lot of times I think that the person who listens me knows a lot of mathematics, but it's not true. And so it's difficult for me, but I'm here. And I am the father of 3 children, and also I have a wife, but it's okay. But I am a University of Chieti Pescara, but I am not in Chieti Pescara. I am in Ascoli Piceno, that is a very small city in Italy, and I want to show you where Ascoli is. Ascoli is in the center of the Italy, in the other part of Rome. And Pescara is, okay, it doesn't work very well, but Pescara is here. So I moved 2 times a week, 3 times a week, from here to here. It is in the Adriatic Sea. Pescara is similar to your city because it's for example, the citizen is quite the same, and he has this university on 2 campuses, Chieti, that is another city, and Pescara, that is a very big city in the Adriatic Sea. Not so beautiful, just like your city, but it's and this is my city. I take these photos by myself because I want to invite you to see my my city, and I'm proud of my city, that is Ascoli. So this is only to make you curious. We have also a good wine, in particular white wine, because it's not so in our region, in my region, it's not so, it's cold, so for the red wine we need a higher temperature. But this is my research topic when I was in Ancona. Yes, because perhaps now a lot of cities, but I earned my degree in Bologna, then I moved in Ancona for my PhD in technical physics, and now I am in Chieti Pescara. I have been also in another university, but now I am there. When I was in Ancona, I studied a lot for two fields. One that is equation of state, because I have the fortune to be side by side with Roman Striek, and I told with your professors today, Roman Striek, and they knows Vera. They made a very important equation of state that is the Vera Striek Vera equation of state. So Vera is very important, and also Striek. Now Striek is retired, he is Polish, and he has about 85 anni. Okay, this is the first. And the other field is thermophysical properties. Yes, because we study surface tension, virial coefficient, viscosity, and thermal conductivity. Historically, the department of Ancona has a great history about thermophysical properties. For example, perhaps the first one was Professor Giovanni Latini. Now he's retired, 84 years. But we are publishing a paper in these days with him, because he is very active, and his equation is listed on Prausnitz. Prausnitz is a very important book that is also in the study in the office of your professor, because today I have checked if Giovanni Latini was in the Prausnitz, and there is, and it's very important. So we studied a lot of thermophysical properties. But now I am in a new department. This is my new department is not specialized on thermophysical properties or equation of state. So I have to shift my research. I don't want, but I have to, because now I am in a department of engineer and geology. So I have to shift my research at 15 and 30, 53 anni I have, and now I have to shift my research. In my department, for example, we study thermal comfort, indoor or outdoor thermal comfort. That is a quite interesting field, because it's important, for example, for architecture, if we are staying here in a comfortable room, or outdoor, if the sun, the air, the humidity is comfortable, for example, for staying outside. And you know, thermal comfort is a problem in Spain, but also in Italy, because with the climate change, we are not able to stay outside, for example, in summer season. It means that we are inside, and then we have refrigeration and so on. So you can imagine that this field is not a secondary. Then we study, for example, solar energy. I spoke with your professor just now, but solar radiation for solar panel, because we are in a department with engineers, and so they are very interesting on solar panel and how solar radiation could impact the efficiency of solar panel. And then we study acoustic. Acoustic, we have a very good laboratory of acoustics, but applied acoustics, not theoretical acoustics, to measure, for example, here, if it's good acoustic and so on. We have a lot of experimental stuff to make measurement. When I was at your age, I thought that mathematics was the queen of all the other science, just like Gauss said, because I studied that field, so I think that there was no other discipline just like mathematics. But you know, when I come to Ancona, and I studied with a lot of physicians, a lot of engineers, very smart people, I recognize that perhaps mathematics is not at the bottom of a sort of pyramids. But the pyramids is flipped of 90 degrees, and perhaps mathematics is the base of all the other disciplines. So perhaps mathematics serves all the other disciplines to make calculation. So in my experience, I have seen that mathematics is a bridge between disciplines. So I can speak with your professor, with engineers, and so on, because I know that we are a common line that is mathematics. During my PhD program, I am speaking for the students because, you know, I think that my experience could be useful for someone of you. When I began my PhD, I was a mathematician inside a department, and I was alone. I was expert in a lot of fields, but I do not nothing of their fields. But nothing, it means zero. So what I have to do there? What can I help my colleague in my department? So I wrote several papers on new equations related on thermophysical properties. But at certain point, I am going to introduce something new that was something new related on mathematics. For example, I introducing a new method to derive equation. For example, when we have a lot of parameters that could affect to one output, we can make, for example, correlation metrics to see what is the best parameters that affect to our output. But correlation metrics is a linear correlation. And what about if we are discussing, for example, on a thermophysical properties that is not linear? So, for example, I wanted to introduce some new statistical methods to see what is the most important parameters that affect to an output. Or, for example, what about the objective function? The objective function is the function that you use when you want to minimize something. For example, you want to minimize the residual. You want to minimize, I don't know, the root mean square error. But are these objective functions derivable? Can I use the derivatives of this objective function? For example, can I use an objective function with the absolute value that is not derivatives? And how this affect to our output? And then I explored advanced technique, such as genetic model and multi-object optimization, yes. And this is, I wrote only one paper about this, but I want to explore much more about this, because, for example, in general, you want to minimize one objective function. That is, for example, root mean square error. But what about the coefficient of determination? That is R square. Because if you want that one objective function is going down, perhaps you want that one other objective function goes up. For example, if you want to minimize root mean square error, at the same time you want that determination coefficient goes 1. That is the maximum. So how to minimize two things at the same time? So we used genetic optimization and multi-object optimization. That is for mathematician, because it's a mathematical model. And I discovered one thing that astonished me, that is that the minimum is not for us. I want to explain this, because you are used, as I use it, that when I am doing the derivation of one function, I find a minimum. The first derivatives of we can see also the second derivatives and see all the design of the derivatives. But with, for example, genetic optimization, you do not have the minimum. You don't reach the minimum. And this is a change of your mind, that mathematics is not just like we have studied in our, for example, pure mathematics. Because if you do not apply mathematics, perhaps you do not see this difference, that minimum is something that if you have 1 year, you can find one thing, one sort of minimum. If you have 2 years of calculation, perhaps you reach another minimum. And for me, that was used for pure mathematics, that the first derivatives gives you the minimum or the maximum, was a very strange thing. But why I'm here, Engel explained very well, because I wrote these 2 papers with your professor, and I have to thank you them, because for my growth these 2 papers were fundamental, not only for my habilitation, because you know, write papers with foreigner scientists is a high impact in my country, but also in your, I can imagine. So it's very, very important for me to write these 2 papers, but also because I learned a method, a new method to stay with others, because this is the first time that we meet each other, but we know perhaps 8 years ago, and we send a lot of emails, but we do not have any relationship, personal relationship. But so I want to thank you, Engel and Isidro, for also for the effort to invite me and for staying me here. But now we are going to tell about neural network. The first time, I know that I am in university, but the first thing that I want you to do is to take your phone and please to answer this question, because so we can understand at what stage we are, what we know about artificial intelligence, and what we know about neural network. Now I'm going to show you the result. When we speak about neural network, there are a lot of misunderstanding about it. And but you know, also when I wrote my first paper, perhaps I have a lot of misunderstanding on my mind. But then I read a lot of papers. I wrote a lot of papers about neural networks. So now perhaps I have a more clear everything. Okay, thank you. Now, then we return on this page. Next in the next slides, but the first thing that I want to explain, I'm trying to explain, is the difference between these four words, because often we use them interchangeably, but they aren't interchangeable. For example, what is artificial intelligence? Artificial intelligence is the broadest word in this system, and it is used to, I think, to classify the machine that wants to learn just like humans. It means that if we want that a machine act just like a human brain, we have artificial intelligence. This is a sentence of Roman that is one of my master, and when I go to Roman with my program, Roman, it doesn't work, for example, to find A and B on van der Waals equation of state. Roman doesn't work this program, and he told me this sentence to tell me the machine is stupid, but you have to be smart, not the machine. It means you are stupid. Roman was very tranchant. And what is about machine learning? Machine learning, as this professor of Stanford, can be defined as the process of introducing intelligence into a system or machine without explicit programming. It means, for example, that if we have a machine just like a laundry machine knows very well how many soap insert, how many times, how many I don't know how many, what is the perfect weights that you have to insert inside to have the perfect washes. But this is not intelligence, because perhaps there is an engineer that have done an if-then-else procedure with all the possibility to have the perfect result. It's not machine learning. It's programming. But if we train a machine to act just like a human, we have machine learning. So, for example, machine learning is in your Netflix for the next film, for the suggested film, because he learns with your choices in the past and suggests you the next film. Or, for example, the music, the suggested music on Spotify. This is artificial intelligence. But machine learning. Machine learning is very good for a lot of tasks, but not for all tasks that for us it's quite simple. For example, to recognize the voice of a man or a woman, to recognize, I don't know, to classify the image recognition. Machine learning couldn't do all these tasks that is very simple for us. So there is neural network. You know, neural network, we can put sometimes deep learning inside neural network or vice versa, because neural network is a backbone of the deep learning, because it is the simpler network that you can imagine, that has only 3 layers, one input layer, one hidden layer and one output layer. If we stack a lot of layers inside the hidden layer, and then I show you, we have the deep learning, the deep neural network that is very difficult to train, that is very powerful for image recognition, for a lot of the problems that we have, we face every day. Different type of neural network. We have the feed-forward neural network that I use because it is used for regression, but also the convolutionary neural networks that are very similar, but it's useful for image recognition, or for the recurrent neural network that is, for example, for stock market, for trends, and so on. We use it, for example, historical neural network, recurrent neural network for the prediction of the weather and so on. But why neural network now is on the mouth of everyone? Because neural network is a very huge topic in the world of machine learning, because often perform very much better than the traditional algorithm. And I will show you some results in just a few minutes. And moreover, the neural network is the base of all the other artificial intelligence programs. So if you want to know artificial intelligence, deep learning, you have to study neural network first. But what is a neural network? A neural network is a computer model that takes inspiration from the human brain, because it's not the same. It's a simplified version of our brain, because our brain is much more complex than the neural network. But it tends to mimic the basic function of our brain. The key idea is that neural network learns from data, but also from errors. This is fundamental to understand that learns from errors. So the learning method is very similar to how humans learn from mistakes and success. And this is a key point. How does our brain works? Our brain is built by millions of neurons. All these neurons are connected with each other, but the connection is not the same for all the neurons. But this electrical signal could be much more stronger or much more weaker, and it depends of the connection. And this is another key point for neural network, that not all the connections are the same. So some are strong because, for example, if we want to learn a new skill, we have to strong that pathway. I mean, if I want to learn how to play guitar, how many times I have to prove the different position of my finger? Perhaps 10 times, 20, 100 times I have to try that particular position of my hand. And then that pathway becomes more stronger. And if you have that accord, you can recognize it, and immediately you can make that position. So, for example, this is a simple example. If I touch a hot pan, my sensors of my hand send a signal to my brain process that signal and send back to my hand a warning telling don't touch and get out your hand as soon as possible. And because this pathway, this answer was fast and correct, this pathway becomes much more stronger. The next time you do not touch that hot pan. Now I want to enter not a lot in the details because we have 6 hours in next days, but I want to introduce the functioning of a neural network, the feed-forward network. This is a neural network is made up of nodes. These nodes are called neurons, which are organized into layers. We can have how many neurons and how many layers we want. We can put 10, 20 layers and neurons, but it's not the same, as you can imagine. But I want to show you that each neuron of the last layer is connected with each the previous neurons. This is connected with N1, this is connected, and this is connected. And this connection is called weights. The weights are not the same, it's not constant, and it's similar to the signal between our neurons. So each neuron is connected with the previous layer with a weight that represents the strength of the connection. So the layers are all the same, but there are 3 layers that are much more important than the others. The input layer that where we feed in the data inside our network. Then we have the hidden layer that is where these data are processed. And then we have the output layer that gives out us the outcome, the output. And all are interconnected. So if we want to go much more deeper, we can see that, for example, see H1. H1 is the output, but please do not think the output as the final. The output is the output of one layer, not the final output. And the input is not the input layer, but the previous layer. So, if we see H1, we see that H1 is connected with X1, X2, X3. If we multiply X1 for W1, X2 for W2, X3 for W3, we have this multiplication. That is a matrix multiplication by a matrix W and a vector X. And then we add an extra parameter that is the bias. The bias is just like an extra parameters to fine-tune the network. So we have this multiplication, we add this bias, and we have H1. But H1 is a raw number, is a number, but a raw number. Because before it became an output, it passed through a function that is called the activation function. The activation function decides if we have to fire or not that neuron. If that neuron is good or not. Sometimes the activation function goes to 0 if is recognized that that output is not good. So when we passed through an activation function, and in our seminars we are going to see how many activation functions we have. We have several activation functions, and we will explain the performance, the better and the worse of each activation function. Then we have the output that is y1. So this is a matrix, this is a vector, this is a matrix, this is a vector, this is a vector, and we apply a function. If we want to, for example, calculate, you can see that the first row, the first column of this matrix is all the weights of H1. The red is all the weights that we have to multiply for x1 and so forth. Then we multiply for x1, x2, x3, we add this and we have h1. Then we pass through an activation function and we have the output. That is specimen. And for the unfortunate students that came for the next 6 hours, we are going to do the calculation by hand. By hand, I mean with an Excel file, because it's. I think that it's very important, because I'm a mathematician, you know, that we are going to do the calculation by hand to understand what is the functioning on this, and we apply also the activation function. So, for example, if we have this neural network with 2 layers, notice that this is the bias. The bias has not input but only outputs. So we have 4 neurons in this hidden layer, 4 neurons with this hidden layer. We can see we can manage also all the calculation of the matrix, the weight matrix. So at the end, the output is the composition of three functions that is passed through in a linear algebra multiplication. I am not going to much more deeper, because otherwise I do not how to say in the next 6 hours. So the advantages of neural network, because you know, also in my mind I thought at the beginning that I have found the gold for all my career and for my you know, for all my papers and so on. But please pay attention on this part, because of course neural network has these very good advantages, that is the flexibility of nonlinear relationship. Because if we stack nonlinear activation function, we can have nonlinear relationship. So, for example, if you use a sigmoid is not a linear function. So we can manage some properties that has nonlinearity inside. Then adaptability to experimental data. It means that for the neural network, data is data, no matter what it means. So I can use the same network for surface tension, for the thermal conductivity, for viscosity, and so on, because it's blind. So I can use it for a lot of things. And it is superior on error minimization, because I will show you. And the reduction of systematic errors. I was talking with your professor 1 hour ago, that perhaps neural network, because do not care what is inside, perhaps, for example, near the critical point, that is critical, not these words is very important, critical, perhaps neural network could manage critical point, because he don't know that is critical point, that is critical, because data is data. And but this is very fundamental, the importance of data quality. In fact, the first 2 hours of our course, tomorrow, is to how to recognize if the data is a quality data, because neural network wants very good data, because it means that it follows the rule junk in, junk out. If you put inside junk, you have junk outside. So it means that we have to recognize outliers, we have to recognize if there are missing data. The quality of the data is crucial for neural network. It means that we have, for example, to minimize the data, the error. We have to see the mean, all these stuffs inside our data. And now I want to show you the quality, because you see this is a friend of mine that teaches me neural network. He works on Google now, and this is the result of neural network, and we can see that all the other model, it's not so good. This is the model, Shafi-Johnson, Sato-Riedel, Garaghezi, also our equation. It's not so good as neural network. This is the same of our paper. This is all the previous model, and this is our neural network. I want to show you that the R square sometimes goes to 1.1. This is also for refrigerants, and I want to show you that RefProp is reference for the refrigerants. And this is the Bible for who wants to study refrigerants. And our neural network perform better than the model of RefProp. For example, for dynamic viscosity. But I say this sentence when I go for example, for some, just like now, all that glitters is not gold, because we have a lot of shortcomings. The first one is the data quality, and we have talked about it. It is a black box. It means that you don't know very well what is going on inside the neural network. But this is not so true. I mean that when I publish a paper, I give all the weights to the reader, because if you want to reproduce my neural network, you can do it. Moreover, we are trying to make also a Python script. If you insert your input, you have the output of neural network. And inside the script that is clear, you can see all the function, all the parameters. So you can find, for example, a sigmoid, and you can see all the parameters of the sigmoid. So you can reproduce the same function. But you know, we are managing, for example, I don't know, 2000 points. So we are going to make a simple neural network. But the neural network that, for example, Gemini use has billion of parameters, billion of parameters. You have seen the last, for example, artificial intelligence, ChatGPT, 60, 80 billion of parameters. And then time consuming. Yes, it means that you have a lot of time to trial and error the best neural network. And also you have to, for example, goes to GPU for neural networks. And then this is perhaps, in my opinion, the greatest shortcoming. Do not exist a universal rule. It means that how many neurons I have to use, how many layers, what kind of function I have to use, what minimization I have to use, what is the learning rate that I have to use. That there are a lot of parameters to fine-tune the network, and there is not a rule. So how to begin an expert on neural network? I think that the best thing is to stay with one that have trained, I don't know, 1,000 of neural network. I have trained in my experience in the last paper that is not published, but I think that I have trained 100 neural network only for one paper. So, for example, if you want to learn neural network, you write me, and I can tell you, you have 1,000 points, how many inputs you have. Well, I can tell you how many neurons, how many layers you have to stack inside. But not because I am a very expert, I don't know. I know only one type of neural networks and 2 or 3 activation function. But, you know, perhaps. So now we are in the summary. I think that this is the summary. Okay, so the future of neural networks is not written here, because I have one idea in my mind, that is to use the Kolmogorov-Arnold neural network. If you are a mathematician, I don't know, you know that Kolmogorov is a huge mathematician, and Arnold, I have studied in the book of Arnold, that is a good physician, a very good physician, and a Russian physician, and I want to use that neural network to apply to my dataset, because I am exhausted to use the sigmoid, true layers, and so on. I want to try something better. Now, if you have the same of before, I want to go with this. Sorry, if you have to write. You have to write, yes, with your smartphone. With this, if with the same program of that we. I will influence AI. Okay, and the last one, and I do not show the result because it's dangerous for me. I do not show the result of this one because it's dangerous for me, and I have quite finished it, but I have also 2 slides, and then I will left you. And I want to give you some only some consideration for students based on my opinion, on my path, on my experience. Do not consider your discipline as the best, and try to contaminate yourself. So work with others with humility and passion. Yes, do not consider you the best one, because you in your mind you have a block that you know everything. So learn to listen, not only to speak, because quite often I stay with a lot of students that speak a lot, but they are not able to listen the advice and so on. Do not be afraid to make mistakes, because this is the learning method. to make mistake. You have to do mistakes. And try to be happy. Yes, because this is perhaps the most important thing in our life. And then, as every respectable presentation, the end is one quotation, famous quotation. I don't know Einstein and so on, but I didn't find anything that is quite good for me. So I invented this quotation that is okay. This is I don't know. Let's learn from neural network. They make mistakes, but every mistake is a step towards becoming better. And thank you. If there is some questions, I'm here, but I know that I'm sorry for my...
What kind of program do you recommend just to start learning neural network and applying?
Program?
Program, yes, or interfaces,
yes.
Python,
yes.
MATLAB, whatever.
Yeah, I train my neural network with Wolfram Mathematica because I am a mathematician, and also in my department we had the license, banally the license of Mathematica, so I'm doing with Mathematica. But perhaps the most powerful is Python at this moment, because Python at this moment has a lot of libraries that can help you to train neural network. So, for example, for the CAN, that is the Kolmogorov-Arnold neural network, just I have seen that there are some Python script to make that quite easy. So I think that you have to, for example, follow some courses that is data analysis for machine learning. I think that this type of course is very important. Data analysis for machine learning.
Bueno, yo voy a hablar en español, creo que no.
Ok, gracias.
Bueno, yo me ha llamado la atención la selección previa de los datos.
Sí.
Yo que trabajé también en hilo tempore, en esto, pues efectivamente pues ya lo sabíamos. Sobre todo en las inmediaciones del punto crítico, donde hay autores que no lo llaman punto crítico, le llaman región crítica, porque es muy difícil experimentalmente determinar el punto crítico. Ahí debe de haber unos errores muy gordos. Digo, en los datos experimentales. Tampoco suelen publicar los autores pues la precisión, o no exactitud serían los matemáticos, la precisión de los datos. Tampoco publican con qué certidumbre me creo yo la bondad o no de este dato. Entonces tenéis ahí un problema, porque luego afinar tanto en el método, si el input ya va afectado, no hay control sobre esos errores, puede pasar cualquier cosa. Gracias.
Grazie professore, e rispondo in italiano.
Sì.
In italiano, perché questa è una questione importantissima, e quando i revisori mi fanno questa obiezione, che è: ma il tuo dato quale incertezza ha? Mi mettono in difficoltà, perché può la rete neurale avere in input l'incertezza? Io non la considero. Faccio questo outcome adesso, io non la considero, ma mi ha dato un ottimo suggerimento, perché è, penso, uno degli input che potremmo mettere per calcolare l'output di rete neurale. Un input potrebbe essere l'incertezza, punti con maggiore incertezza meno importanti per te. Grazie, mi ha dato uno spunto per i prossimi paper. Ok, thank you. Grazie tanto.